Okay. Okay. Good evening. Something totally different from what you're used from me, and that is statistics, science, mathematics. And I wonder, and I'm asking you via this video to help me out with this, and it is, what is the chance that a coin with a flat edge on it will end, if you toss it like that, that it ends on its edge. Of course, it's a very thin edge, so it's hard to get it on the edge right now. But what is the chance of when you toss a coin, you have head and you have a coin, but you also have an edge, and there is a non-zero chance that if you flip it, if you toss it, that it will end on its edge, like this. Yeah. What is the chance? How can you calculate it? Well, I've done some experiments myself in the recent past, and what I did is I tossed coins like 100 times, and let's see how often it hits the edge. It will remain on its edge. Well, what I've also done is, and that's the next thing, I increased the thickness. What I did is I glued two coins together, two of the same coins together, and I again flipped it 100 times. And let's take note of the times of it ending of its on its edge. The chances are increasing. What I also did is with 3 coins and tossed it 100 times. What I also did is with 4 coins glued together, etc., etc., etc. So in the end, I had some about 12 coins glued together. Unfortunately, they fell on the ground. I used a second secondenlijm, very fast cyanic based glue to glue them together, and I tossed them. But what happens, it turns from a coin slowly, adding more and more coins, into a rod. And of course, as I saw, is that what you get is an S kind of curve, like this, an S curve. And I'm asking your help to find the equation of the curve. I have of course my own equation of that curve of these coins. These are called what we call them 5-cent 5-cent coins, European 5-cent coins, and they have of course a specific kind of measurements, dimensions. In diameter, but also in thickness. It's about 21 millimeter in diameter and 1.67 millimeters in thickness. So what you get is an S curve, and what you should do also, what I can advise, is not adding the thicknesses of the coins, but actually the thickness of the glued coins, because it becomes a function of the thickness, and of course in this case also of number of coins. But since there might be some spacing between the coins due to the glue that you add, it may be a little bit thicker than you get if you calculate it based on the individual coin thickness. So the best thing is to do is measuring the thickness of the total. So, but the chance that it ends on its edge, like you see, is increasing the higher number of coins you get, and so that's why you get an S curve. In the beginning, the chance is very low, but it's not zero. It's non-zero. I found out that the chance is about 0.5%, give or take. A couple of tenths of percent or a couple of hundreds of percents. But for one coin, it's about 0.5% that it ends up on its edge. But the more the coins you glue together, the more, the bigger the chance is that it ends on its edge. And like a rod, if you suppose that you have 100 coins glued together, then it's a rod, and the chances are very minimal that it ends on a coin or the face or the coin. So that's at the top. Then it's almost 100% that it ends up on its edge. So that's what you expect in an S-curve. Okay, hope you can fine-tune this little research, big name for something small like that, with me together. I tossed it about 100 times. I can give you the numbers in a table below here or in the screen. I'll show you in a moment. But I'm curious. Maybe you can help me. I mean, tossing coins thousands of times, taking a lot of time. So if you let more people do 100 times, for example, that takes lesser effort of my part. But also measure the dimensions of the coins and the glued coins together. Measure the dimensions, please. Okay, thanks for watching. Thanks for helping in advance, and see you next time. Bye bye. Hasta la vista. Hasta la vista. I mean.